Okay, let's do step one, okay? Step one is to draw the forces, right? So there's going to be an upward force here, T1. There's going to be an upward force here, T2. Obviously, I think T2 is going to be larger, right? Because the person's standing on that side. There's going to be the force of the beam, right? And the force of the beam is going to be acting right at the center of gravity of the beam, right? So that's going to be 56 G, and let's just pivot from the left side. Let's just say that that's our R equals 0. So that is 6.1 meters long, right? So this is at 3.05 meters from the left side. Okay, and then there's a force of gravity acting down from the person. And that's going to be 72 G, right? And the person is 1.1 meters from the right side. So that makes them 5 meters from the left side. So at 5 meters from the left side. Right, and then T2 is at 6.1 meters from the left side, from the left. Okay, so let's set up our x expression. Our x expression looks like this. Oh, there's no x expression. It's just 0 equals 0. Okay, let's set up our y expression. Yeah, so this is one of those ones where there's nothing's in the x direction, right? Okay, and in the y direction, I've got T1 minus 56G minus 72G, where I'm saying here G is 9.81. I'm just too lazy to write 9.81 so many times. And it doesn't help me, right? Okay, so T1 minus 56 times 9.81 minus 72 times 9.81, right? Plus T2 is equal to 0. All right. And then let's set up our torque expression, okay? So our torque expression is going to look like this. Okay, and I'm going to torque about here. I'm going to say this is R equals 0. So we'll torque about the left side, okay? So we've got 0 times T1. Doesn't matter whether it's plus or minus, it's just 0, right? This is a clockwise torque from this guy, right? So plus, then where is it? It's 6.1 meters long, so it'd be 3.05 meters out. 3.05 times 56G. So if that's 56 times 9.81. Okay, plus, and then how far is this person? They are 5 meters, so 5 times 72G. And then minus, how far is that guy? 6.1 meters. So minus 6.1 times T2. And that adds up to 0. All right. Now, because I chose to pivot about a point where the unknown force is acting, that eliminates that variable from this expression. And now it's solvable. We have only one unknown, and that's it. Okay. So that guy is going to be, I'm not going to use my solver. I'm just going to do this. 3.05 times 56 times 9.81 plus 5 times 72 times 9.81. Get that. And then I'm going to divide by 6.1. 853.6. So that's good. So T2 is 853.63 newtons. So I've got one answer. And now I'm going to plug in here and get the other answer, right? Okay, here we go. Okay, so I'm going to go T1 minus 56 times 9.8. That's what I'm saying by that, right? Minus 72 times 9.8 plus 853.63 is 0, right? So now I'm set. Now I can solve for T1. Okay, so it's simply going to be 56 times 9.81 plus 72 times 9.81 minus that 853.1. 402 is what I get. That's a 4. Okay. My dog wants to come in. She's like, you're in there all by yourself. You need company. All right. There you go. So in these ones, there is no X expression, right? If the forces are all straight up and down, if it's just forces straight up or straight down, and then gravity, that one's 0, right? And then you just set up torque. If you pick a spot where one of the forces acts, you can eliminate a variable, and then you can solve the torque expression, make that solvable, plug into the y expression, and you can get the other variable. Okay?